Number 9. Take a gander. Y equals x squared plus 10x minus 9. So we leave the 9 alone. We want to complete the square on this. 10 divided by 2 is 5. 5 squared is 25, so that's what we need to add in. I get x squared plus 10x plus 25, and the square has been completed. And I have minus 9 from earlier, and then I subtract 25 to counteract. So this becomes x plus 5 squared. Notice, keep the sign, divide by 2. 10 divided by 2 is 5, and I get minus 36. So my vertex is at negative 5, negative 36. Does that answer your question? Oh, you can't see. Oh, it's because I am not live. That's why. Take a gander at my math here. Let me know where your question is. Maybe my dictation was sufficient. Does that answer your question? You're right. I just can't add. Thank you. 34. So the vertex is negative 5, comma, negative 34. We all make mistakes. So is that good? Given that? Okay, cool. Anything else, y'all? 10, you bet. Negative x squared minus 6x minus 9. Leave this negative 9 alone. I need to factor out the negative. Is this okay so far? And I need to complete the square. So 6 divided by 2 is 3. 3 squared is 9. So I add 9. What did I just create? I created negative 9 units. Well, I need to do the opposite, so I add 9. So here I get, this negative stays on the outside, this factors as x plus 3 squared. Keep the sign, divide by 2, 6 divided by 2 is 3. Negative 9 plus 9 is plus 0. And you don't have to write plus 0, it can just... So does that answer your question? How did you get plus 9? This plus or that plus? Left or right? Between the x and the 6? Oh, so I'm looking at negative x squared minus 6x. If I want to factor out a negative, I'm basically dividing by a negative 1. So if I divide by a negative sign, this becomes positive. If I divide by another negative sign, this becomes positive. And you can also demonstrate this by distributing. So you get negative x squared minus 6x. Does that answer your question? Just anti-distributing the negative sign. When you factor out a negative sign, it changes all of your signs. It flips them. Does that answer your question? Cool. Cheyenne, you got a question? I wish my eraser were bigger. Yeah, I got you. Thank you. Alright, let's get into it. What is a matrix? Well, you've seen them before, right? Have you seen matrices before? Can you let me know with a yes or a no? A matrix is usually denoted with a capital letter. I'm just going to use M right now for matrix. We haven't seen matrices before. Okay, well that's fine. I was just going to teach from the ground up anyway. So I'm just going to make a matrix just from scratch. And let me make it before I describe what it is. Okay, here's a matrix. A matrix holds entries with respect to rows and columns. It's like an array, or it's like a grid. You can think of it kind of like a grid. It just doesn't have those grid lines. So those grid lines are never written, but that's what it's like. The 1 has nothing to do with the 3, and the 0 has nothing to do with the -5. So a matrix holds entries, and we call these elements. So each of these guys is an element. And also matrices, so matrices is plural, matrix is singular. Matrices have dimensions. And by dimensions, I mean rows and columns. So let's count how many rows there are. It's like if you were in a theater or a classroom. That's 1 row, 2 rows, 3 rows. So there's 3 rows. Are you on the app, Bryce? And then columns, I think, are like pillars, like Greek columns, right? That you would see if you went to Athens. That's a column. There's 1 column, 2 columns. So we say the dimensions of M are 3 by 2. Rows always comes before columns. We can ask for a certain element of the matrix. And for example, let's say find M3, 1. This means row 3, column 1. So what's in row 3, column 1? Well, that's 1 row, 2 rows, 3 rows. And here's the first column. So M3, 1 must be 10. Notice it really says 31, but this is expressed as M3, 1. We're never going to deal with dimensions that are more than 1 digit. So this first number is always row, and the second number is always column. First number is row, second number is always column. That is not distinguishable at all. Let's use pink. So remember this order. This is going to be important for all of matrices. Rows before columns. Okay, I'm going to write a new matrix. And look, I didn't even mention, matrices can hold anything. Each element can be anything. It can be a number, a decimal, a fraction, a variable, so anything like that. Okay, so let's see. I'm going to make a new matrix. I'm going to call it A. Capital letters denote matrices. And so I'm going to make A, and it's going to look like this. Okay, so I would like you to find the dimensions. Number 2, find A 1, 3, and 3, find A 3, 2. So do these 3 problems really quick. and let me know when you finish. Did y'all see snow last night? Because I saw snow last night, and it was crazy. I took my dog outside and I saw the snow. I'm from Florida, y'all. Driving. Can I explain what? What's your question? Do you have a question about dimensions or these indices? This is the index. Plural indices. I asked you two questions. You can't say yeah. Is it about dimensions or indices? Both. Okay. Dimensions are how many rows and then how many columns. Rows are like rows of seats in a classroom or a theater. Okay, so there's 3 rows for M. Columns are kind of like, I always think of like a concrete pillar. How many pillars are there? Well, there's 1, 2 pillars. So there's 2 columns for M. And when you index an element, this means 3rd row, 1st column. So I go to the 3rd row. That's 1 row, 2 row, 3 rows. And this is the 1st column, and that's the 2nd column. So in the 1st column is 10. Or you can think of it as, what's the first entry in row 3? So I can go to row 3 and look at the first entry. Row 1, 2, 3, the first entry is 10. Does that answer your question? Alright, take a quick moment to do these 3. So we definitely haven't seen these before, y'all. I feel like y'all did these in Algebra 1. Maybe not. Maybe that's... Has anybody seen these before? If you have, let me know. But we're learning from scratch anyway, so you shouldn't worry. Never seen it before. Well, here they are. Are we all done? Is anybody still working? If you're done, please let me know. Dunzo. Miles is done. Okay, so let's go over this. So the dimensions of A, how many rows are there? There's 1 row, 2 rows. 2 by, there's 4 columns. So it's 2 by 4. A13. So I go to row 1, entry 3. Well, here's the first row, and the 3rd entry, that's 1, 2, 3, will be Y. So A13 is Y. And A32, that's row 3, column 2. So I'll go to row 3. There's no row 3. So this is not possible. Any questions about these 3? By the way, I didn't mention what matrices are used for. Matrices are usually used to hold coordinates. Like these could be XY pairs. So that's 1, 3, 0, -5, and whatnot. So you can represent, for instance, a picture with matrices, and it has all your coordinates, all your pixels, the shade of the pixels, and whatnot. And to be able to do math on a matrix lets us do image processing, math in multiple dimensions, higher level physics and everything. Matrices are very important for later math and sciences, so they're very useful. So let's continue. So we know how to find the dimensions of a matrix. We know how to find their indexed elements. Let's talk about matrix addition. Matrix addition is only defined, so we say matrix A can be added to matrix B only if A and B have the same dimensions. Same for subtraction. So these can only happen if they both have the same dimensions. Let's try adding them. So I'm actually going to write 3 matrices. Whoops. So let's write A. I'll make it 2 by 2. Let's write B. And C. Alright, so let's just use what I had from earlier. Let's do A plus B. So let's find A plus B. First of all, are they the same dimensions? They're 2 by 2 for A and 2 by 2 for B, so they can be added. I'm just going to go ahead and write them out even though they're here. So I get 1, 4, 0, negative 3 plus 7, 10, 1, negative 5. And the way you add matrices is we're going to take corresponding elements. So we started with 2 by 2s and we're going to end with a 2 by 2. The dimensions do not change. So this element, right, there's going to be 4 elements. 1, 2, 3, 4. This first one is going to come from that same area. So this will come from 1 plus 7. So we get 8. This will come from 4 plus 10. So we get 14. This will come from 0 plus 1. So we get 1. And the last one will come from negative 3 plus negative 5, so I get negative 8. Any questions about adding these matrices? Am I recording this? You bet, man. Alright, let's also try B minus A. So I have B, that would be 7, 10, 1, negative 5. By the way, when you list the elements of matrices, you always go across the row and then down. So it's like you have to go to the end of the floor to get to the staircase. So to talk about A, you say it's 1, 4, 0, negative 3. So B minus A would be minus 1, 4, 0, negative 3. So this will result in another 2 by 2. And the first element is 7 minus 1, 6, 10 minus 4, also 6, 1 minus 0 would be 1, and negative 5 minus negative 3. That's kind of complicated, so I'm just going to write it off to the side. Negative 5 minus negative 3 would be negative 5 plus 3, or negative 2. So we get negative 2 here. Any questions about subtraction? And lastly, I'm going to erase this just for a moment, and I'll put it back here in a second. Let's talk about B plus C. Well, first of all, are they the same dimensions? B is a 2 by 2, and C is 1 row, 3 columns. So B plus C is not possible. The dimensions are not compatible. So let me get my... There we go. Any questions about addition and subtraction? Alright, let's write a couple of these. Well, it's a blank screen right now, but I'm writing. Can you see now, or is it buffering? Is it loading? Well, I'll send you a picture here in a second. So, I would like you to find, please, a plus b and also a minus b. Can you see it now, Bryce, or do you need a picture? I got you. Here you go. Let me know when you finish. Is anybody still working, or are y'all done? If you're done, please let me know. Done. Thanks, Peyton. How's the TikTok fame, Peyton? How's that going? Alright, let's do 1. So 1 is fine. They're the same dimensions. So I get -3 plus -2. So that is -5, 1, 7, 8, 1, 1. 200k followers. Dang, man. And then number 2, I'll give you the answer here. -3 minus -2 is -1. 5 minus -4 is 9. 0 minus 7 is -7. 7 minus 1 is 6. 6 minus -5 is 11. And 2 minus -1 is 3. Did you guys get these, or do you have a question? Alright, so addition and subtraction are pretty easy. I have something else to show you, and that is matrix multiplication. Okay, so matrix multiplication is only defined for matrices A and B. What do I want to do? So A is dimensions m by n. These are just placeholders. Don't worry about the letters. And B is dimensions n by p. In other words, when you write them next to each other, these inner numbers have to match. Notice this is the columns of A and the rows of B. So let's actually put a formal example to it. So if I have A of 1 by 3 times B of 3 by 7, are they compatible? Do these match? Yes. And the output, by the way, I didn't even write this. If you multiply these guys, you get a third matrix that is these other letters, m by p. So they're compatible, and the new matrix will be 1 by 7. Let's try another one. If I have A that's 2 by 5 and B that's 5 by 3, are they compatible? The inner numbers match, yes, so the result is the outer numbers. It's going to be a 2 by 3. Let's try another one. If I have A that's a 1 by 6 and B that's a 3 by 6, are they compatible for multiplication? The inner numbers don't match, so it's not possible. I would like you to try a couple of these. So if they're possible, just tell me the result dimensions. And if they're not possible, tell me not possible. So the question is result dimensions. Whoops. Well, I haven't shown you how to multiply yet, but multiplication is not defined for when these numbers don't match. Is that okay? Or do you have another question? Mathematicians have only defined matrix multiplication for when you have these compatible matrices. Try these three, please. And notice I haven't put a multiplication sign between them. It's kind of implicit, but you can write it. That's fine. If they're put together, it means multiplication. This shouldn't take you too long, so please let me know when you finish. She's done. Alright. So 3 by 5 and 5 by 7, that's good. We will get a 3 by 7. 2 by 5 and a 2 by 5, it's not possible. They can add or subtract, but they cannot multiply. 1 by 6 and a 1 by 3, you get a 1 by 3. Okay, so that's how you decide if they're compatible. Can they be a couple, or are they just not romantically compatible? So let's talk about how to multiply 2 by 2 matrices. let's see. I want lots of room for this, so I'm going to start a new page. Today is the 14th. New page, please. Okay, so consider two matrices, and I'm just gonna I would give you the rule of multiplication, but first I want to show you really how it goes. So let's multiply two matrices, 1, 2, -3, 0, times -1, 5, 1, 3. So first of all, we need to decide, are they compatible? Well, it's a 2 by 2 and a 2 by 2. The inner numbers match, and the result is going to be another 2 by 2. So let's see. I'm going to have 4 elements in this result. And actually, you know what? I'm even going to color code these. So we're going to have this cyan one. We're going to have a red one, a blue one, and a green one. Okay. Let me go ahead and index these elements. So this is row 1, column 1, row 1, column 2, row 2, column 1, and row 2, column 2. So let's find the cyan element. So cyan, that's row 1, column 1. Now the reason I ask to index these is because this helps. If I want row 1, column 1, that means I'm going to have to use row 1 of the first matrix and column 1 of the second matrix. So let's see. Then column 1 of the second matrix. We also haven't defined how you multiply rows and columns, so I'm going to show you that now. The way we do this is I'm going to take these two numbers, 1 and -1, and I multiply them. So this becomes 1 times -1, and I'm going to move over to the next element, and I'm going to move down to the next element. So I get plus 2 times 1. And so that's 1 times -1, that's -1 plus 2 equals 1. So this is 1. And to tell you how to multiply these again, you do 1 times -1 plus 2 times 1. So there's like this action. You're going to start at the beginning of the row and the beginning of the column. You're going to multiply those, and then you're going to go down 1 in the row and down 1 in the column, and you're going to multiply those. And you're going to keep going until you've exhausted the row and the column. Okay, let's do the red one now. The red one is row 1, column 2. So that means I need to use row 1 and column 2. Let me erase this really quick. And this is going to seem hard at first, but it's going to become very natural. Promise you. So this isn't easy. If this is a little hard for you, don't worry, that's natural. So I need to use row 1 and column 2. So here's my row 1. Whoops. And here's my column 2. Also, notice, if you were to overlay these, row 1 and column 2, that's where this guy is. See how they have the top right element in common? So they make the top right element, if that makes sense. So the way this is going to happen is 1 times 5. I start at the beginning of the row and the top of the column. 1 times 5. Now I'm going to move one position in the row to 2. I'm going to move one position down in the column to 3. So I get 5 plus 6. That's 11. Okay. I would like you to please find this blue element. That's row 2, column 1. Please find that really quick, and we will talk about it. So it does work. Except I don't want that. Let me know when you're done. So, I'll give you a tip here. Let me erase these really quick. Sorry, this is tedious. Let's see. Wish I could more precisely erase these quicker. Okay, so what's the index of blue? Well, it's row 2, column 1. So let's write that down. Row 2, column 1. That means I'm going to use the row 2 and then the column 1. Let me know when you finish, please. Anybody still working? Is anybody finished? He's done. Done. So if we're going to use row 2 and column 1, that means we need this guy and this guy. Row 2, column 1. Notice they share the bottom left element. So they will make the bottom left element. So I get -3 times -1. Start at the beginning of the row and the beginning of the column. Then we're going to move 1 down and 1 down. So I get +0 times 1. And 0 times 1 is obviously 0, so I get positive 3. So I would like you to also please find this green element. Find this green element at index 2, 2. Or even another way to think about it, notice we're asking for the bottom right. So we need to use the bottom and the right. Does that make sense? And again, if you were to overlay these, they intersect in the bottom right corner. That's the index they share. And so that's why it creates the bottom right corner. So please let me know when you finish. In high school, I never understood this. This was a freaking mystery to me. I'm going to assume y'all are still working because nobody has told me they finished. By the way, you guys are still doing such a great job. Miles finished. Evan finished. Alright, let's go over this. We want row 2, column 2. Whoops, I circled it in white, but that's fine. Row 2, column 2. So I'd get negative 3 times 5 plus 0 times 3. So that will be negative 15. Well, we have all 4 of our numbers now. So it's 1, 11, 3, negative 15. That's our answer. One 11, 3, negative 15. So we have this. And this equals 1, 11, negative 3, negative 15. Positive 3. I'm gonna ask y'all, let's see. I'm gonna show you how to do, I'm gonna walk through one more example. We can do blue. Don't have enough space really. That's fine. So let's say we have 3, 0, negative 1, negative 2 times 1, 2, 3, 4. In fact, I'll do negative 2. So we already know that 2 by 2s are compatible, so I'm going to go ahead and start multiplying this. So this is going to be another 2 by 2, and we're going to have 4 elements. Row 1, column 1, row 1, column 2, row 2, column 1, and row 2, column 2. Okay, so once you get used to these, this is how I like to start going along. Okay, so I'm just going to put my answer here, and we're going to fill it in as we go along. So I'm looking for the top left element. So I need to use the top and the left. So the top gives me, and let's see, we'll do this. So I'm going to use the top and the left. So this is cyan. So I get 3, 0, and 1, 3. So it's 3 times 1 plus 0 times 3. Well, that's just 3. Now, wait, let's not do that. So I'm going to move over to 1, 2. So if I'm moving to the right in my answer matrix, that means I need to move to the right in the rows and columns I'm using. So I can't move to the right here, so I move to the right on what I'm using. So if I'm looking for the top left entry, I need to use the top row, the top right entry. I'm going to use the top row in the right column. So let's take a look at that. So this is what we got. I'm looking for top right, so I use top and right, or otherwise that's row 1 column 2, right? So I'm using row 1 and column 2, so I get 3 times negative 2 plus 0 times 4. So it would be negative 6 plus 0. So now we're ready to talk about yellow. So notice I'm moving from the top right to the bottom left. So I want to use the bottom and the left. So let's erase this and get our blank matrix back in. So I'm talking about the bottom and the left. So we got bottom, left. So I get negative 1 times 1 plus negative 2 times 3. That is negative 1 plus negative 6, that's negative 7. And lastly, we can do pink. So we're in the bottom right, so we need to use the bottom and the right. So I get negative 1 times negative 2 plus negative 2 times 4. So this is positive 2 minus 8. It's negative 6. And here's our answer. I'm going to put it in a little cloud. So just remember, always rows before columns. Notice we never discuss the columns of the first matrix. And we never discuss the rows of the second matrix. When you multiply, it's always rows and columns. So we want these rows. The product of these two matrices depends on the rows of matrix 1 and the columns of matrix 2. Do you guys have any question about multiplying matrices? It's pretty crazy, right? It's not too bad. You guys are going to get really used to it. And so that's the last thing I have for today. I'm going to post the homework to the portal. If you have any questions, let me know. And I'm also going to, as always, there's going to be a video. So this is, oh goodness. All right. Have a great day, y'all, and peace.